Welcome back to All This Math. This is Professor Parker. Please make sure you are subscribed to the channel. Make sure you like this video. Drop a comment down below in the comment section. If you have any questions about anything I go over, put your questions in the comment section. And last but not least, share this video with at least one other person. All right. Now, what are we doing? Well, first, what we're going to do, we're going to shout out Coppin State University. All right. My rival, I, of course, am a graduate of the national treasure, Morgan State University, class of 2003. But, Coppin is across town, but Coppin is still a historically black college and university. So I have respect for Coppin University, Coppin State University. All right. And I like to promote the HBCUs. You know that if you watch this channel, you know how I get down. You probably seen another video where I had this sweatshirt on. All right. So anyway, shout out to Coppin State University. And we're about to talk about the intersecting chords theorem. The intersecting chords theorem. The intersecting chords theorem is one of them many theories in geometry that enables us to solve for missing lengths within a problem. In particular, in a circle. In this situation. Now let's look at the question. It says to determine the length of JH. JH is this segment right here from point J to point H, right? If YH from this point to that point is 7 centimeters, HC is equal to HB, right? And HB is equal to 3 centimeters. Now, if HC is equal to HB, watch this. If HC and HB are the same thing, then that means that HC is also equal to 3 centimeters. That's going to be important. Now look what I did here. All right. Here's your little history lesson. All right. I'm a name drop for you real quick. JHC. Those initials stand for John Henrik Clark. I'm gonna say it again. John Henrik Clark. I was being intentional. That's why I chose these letters to represent these points. John Henrik Clark. Do your research on John Henrik Clark. Look up some of his books. Look up some of his lectures on this channel on YouTube. Right. Very informative. One of the greatest historians ever of all time, right? Did a lot of work for our people. Okay? You should be familiar. Also, look what I did here. YBJ Yosef Ben Jokanan, right? Affectionately known as Doc Ben or Dr. Ben, all right? A contemporary of John Henrik Clark. Yosef Ben Jokanan, all right? Or some people say Joseph Ben Yakinen, all right? Doc Ben, Dr. Ben, Dr. Ben, and Dr. Clark. Dr. Clark, the C for Dr. Clark, the B for Dr. Ben. All right. That's your little history lesson. I just when the name drop those two. If you're familiar with them, cool. If you're not familiar with them, go start researching them. All right. Dr. Ben also wrote several books, just as Dr. Clark did. All right. Now, what does the intersecting chords theorem say? It says this. Well, first of all, JC is a chord and YB is a chord, right? Chords are found inside of a circle and they touch two parts of a circle. That's what a chord does. Now, a diameter is a chord. It's a special chord because a diameter is the only chord that goes through the center of the circle. See this point right here? This is the center of the circle. So this is not a diameter. This is not a diameter. How do you know that? Because neither of these chords touch this point. They don't go through that point. All right. So now, the intersecting chords theorem. So they intersect each other where? At point H, right? It says this. If you got two chords that intersect inside of a circle, the length of one segment of the chord multiplied by the other segment of the chord is going to be equal to, in the other chord, one of its segments times this other segment. And the segments are broken up by, of course, where they this point where they intersect. All right. So basically, this part times this part is equal to this part times that part. Again, this part times this part is equal to this part times that part. That's the intersecting chords theorem. And if you know that theorem, then you can set up an equation. Once you set up the equation, we use algebra to solve for what we try and look for, and then we come up with an answer. That's why I say geometry, which is what this is just algebra 1 with shapes. That's all it is. But you got to be strong in algebra to do geometry. You got to, or else you're not going to be able to figure nothing out when it comes time to solve the equations. All right, so look, let's set up our equation. So we saying this, but we're saying JH times HC. John Henrik. His name was Henry. His middle name was Henry, but then he read a certain book and was influenced by this character and then changed his middle name from Henry to Henrik, right? After that character in that book. JH, John Henrik, times Henrik Clark, right? So this segment times this segment is equal to this segment times that segment. So we got YH times HB. All right. Now we're just going to replace everything we know. Determine the length of JH. So we don't know what JH is. So let's create a variable for JH. Let's call that X. Do we know what HC is? Yeah, we do. We know HC is equivalent to, or congruent to HB. HC equals HB. So then HB is 3 centimeters. So therefore, by the transitive property, HC must also be 3 centimeters. So we're going to replace HC with a 3. Equal sign. What's YH? YH is 7. Boom. There we go. HB, what's that? That's 3. Boom. Okay. So now we got X times 3. We can rewrite that as 3X. 3 will be your coefficient. Coefficient, that's algebra vocabulary. Make sure you know your math vocabulary, your algebra vocabulary. Coefficient is the number in front of the letter. It tells you how many of the variable you have. How many X's we got? We got 3 of them. And then 7 times 3 over here, that's 21. Make sure you know your multiplication facts. Make sure you know your multiplication facts. Now, how do we solve for X? We get rid of this 3. Or if you want to be fancy, you can say we eliminate this 3. How? Doing the opposite operation. What is 3X doing? Multiplying. 3 is being multiplied by X. So we do the opposite operation. Boom. Divide by 3 on the left side. Also do it on the right side. Divide by 3 on the right side. 3 divided by 3 is 1. So you're left with 1X. 1X is equivalent to X. We don't say 1X. We just say X. It's like slang. It's more efficient. It's vernacular. Instead of saying 1X, we say X. Because how many X's do we have? We have one of them. So if you just have an X, it's already understood that you only have one of them. You don't got 2 of them because there's only 1X written. It's only NX written. All right. So we got X. And then know your division facts. You need to know that 21 divided by 3 is 7. So X equals 7. So therefore, let's see, we replaced JH with X. So we saying JH is equal to 7. Boom. And that's how you use the intersecting chords theorem. That's it. Ain't nothing too crazy. All right. Ain't nothing too crazy at all. That's the intersecting chords theorem. All right. So make sure you subscribe to the channel if you're not already. Also, drop a comment down below. If you didn't understand something I put up here, that's cool. Just put your question in the comments and I'll get back to you. All right. I might make another video specifically addressing your question. All right. Start asking questions. All right. Excuse me. Like the video if you didn't already, and please share this video with somebody. All right. See y'all later. Peace.